as it does today. That would have been quite a sight.
On our devastated planet, it's hell on Earth. Volcanoes spew. The crust heaves. Lava rolls like an ocean. The moon is so close that rock and magma are tidal. The lunar pull is 4,000 times greater than today. Earth writhes and belches. In the seas, every wave is a tsunami. Gradually, through 4.5 billion years, Earth cools and calms. Initially, vast tidal forces cause the moon to rapidly pull away. The spin of both bodies slows. Our day lengthens from 4 hours to 24. Tidal action continues to slow the spin of Earth and keep the moon in retreat. Scientists know by examining rock layers called tidal rhythmites. They show the frequency of prehistoric tides. Marjorie Chan of the University of Utah hunts rhythmites in Big Cottonwood Canyon. Eons ago, these were layers of sediment left by tides in a river estuary.
Some of these tidal rock layers are just paper thin, and it's like each piece of paper is a story or page out of a diary telling what's happened a billion years ago.
Chan's findings are rock solid. Primitive tides are more frequent, and the days far shorter.
It's amazing that these tidal rhythmites can tell us that a day was only 18 hours long, because we can count some of the tidal rhythms. We can see how many rhythms were in a day, how many days were in a month, how many months were in a year, and we use those calculations to show how the moon has been moving away from the Earth over time.
From 14,000 miles at the start, the moon is now 234,000 miles from Earth. Today, when all three bodies align, the moon can precisely cover the sun. On Earth, we see it as a total eclipse, an astonishing cosmic coincidence. Such eclipses are further evidence that the moon is receding from Earth. This is a total eclipse today, but it looked like this when the moon was closer to Earth. In future, when the moon is further away, a total eclipse will be a thing of the past. Ancient eclipse records reveal that as little as 2,000 years ago, day length is fractionally shorter than today. Had it been constant, the solar eclipse of 136 BC would have followed this line of totality. Instead, because the day was then shorter by a 20th of a second, totality sweeps east through Babylon. More than a quarter century ago, Apollo astronauts set up reflectors on the moon. Today, they're targets for astronomers at the McDonald Observatory, Texas. By bouncing laser beams off the reflectors, the speed at which the moon is receding can be measured to within a hair's breadth. The gap is widening by 1.5 inches a year. From this, over 4.5 billion years, the moon in our skies has shrunk to this. The moon's gravitational pull keeps Earth on an even keel, an average tilt of 23 degrees. By contrast, Mars lacks a big moon stabilizer. Consequently, it wobbles on its axis. Over millions of years, the tilt can vary from 0 to 90 degrees, playing havoc with its climate. Imagine Earth like this. In Paris, at the Bureau de Longitude, astronomer Jacques Lascar does just that. What would happen to Earth, he wonders, without our big, lucky moon? First, he models Earth with the moon. Our axis may move in a circle, but always at 23 degrees. Remove the moon, and the circular movement slows, but Earth goes loco. Lascar's calculations spell chaos. Take out the moon, and we lose all stability. Earth reels around the inner solar system. Lascar has no doubt we depend utterly on our partner in space.
If we had no moon, the axis of the Earth will wobble chaotically between 0 degree and 90 degree. And the climate on the Earth would change dramatically. So we can say that the moon is a climate regulator for the Earth.
Even with the moon, Earth suffers many wobbles. As a member of a NASA team seeking the origins of life, Lynn Rothschild knows that even the smallest change in tilt has profound effects.
There's some researchers in Germany that have proposed that the reason that civilization on Earth started in the Nile Delta region and not the Sahara, where there were large groups of humans at the time, was because of the obliquity of the Earth shifting less than a degree.
North Africa's lush Sahara turns brown and barren. Today, it's Earth's biggest desert, product of a planetary teeter.
Without the moon, we would be getting shifts in obliquity of 20, 30 degrees, 40 degrees, 50, more. And so compare that to this change in obliquity of less than 1 degree that caused the mass migration of humans, and you can start to imagine what a serious issue this would be for life on Earth.
So, as we lose the moon, there's cause for concern. Could this be Egypt as Earth starts to wobble? Is this the Sahara of the future? Does Antarctica become a blazing desert? These are the prospects if we lose the moon and Earth tips over.
You suddenly have summers that are incredibly hot. Over land, you're talking about maybe over 100 degrees centigrade, over the boiling temperature of water. On the other hand, you have winters where you're well below freezing, maybe as cold as even dry ice, incredibly cold temperatures.
Ice sheets advance and retreat across the equator. Worse still, as Earth wobbles chaotically, the polar caps melt, the oceans flood, islands disappear, our coastal cities are inundated. It's a fact. The moon is leaving us. The further it goes, the less it will stabilize our planet, and the slower Earth will rotate. Our day will get longer and longer. One means of slowing the moon's retreat could be dam building, not across rivers, but oceans. It's science fiction, but we have millions of years to develop the technology. We're losing the moon because of tidal friction. Reduce the ebb and flow of our oceans by damming them, and we could slow the rate of the moon's recession. Equally bold is the idea of the late Alexander Abian of Iowa State University. He suggests hijacking a moon from Jupiter and parking it in Earth orbit. This moon, Europa, is big enough for the job. It doesn't replace the moon. Europa just helps keep our planet upright as the influence of our moon declines. But full moon spells trouble ahead for hospitals, prisons, and the streets of any city.
It just seems as though something tends to happen when it gets a full moon. You always seem to have some kind of problems. It just seems to be something in the air that gets people excited, sometimes in the wrong way.
From new moon to full moon, science explains the lunar phases. They're because only half the moon is sunlit, and we see a varying amount of that half. What science doesn't always explain is the effect of these phases on terrestrial life. Why is the practice of certain yoga thought to be dangerous at full moon? Are more babies born at full moon? Does the moon's 29.5-day orbit of Earth, the lunar month, influence the menstrual cycle? For primitive man, full moon means that he has light to hunt. There's a theory that this has locked the menstrual cycle to the lunar cycle. While men hunt, women can afford to be infertile. But in the dark days around new moon when men are at home, women should be fertile for the survival of our species. In nature, once a year, pololo worms rise to the ocean surface to mate on the night before a new moon. Easy pickings for these South Sea islanders. Coral spawns on the Great Barrier Reef. It only happens at full moon in November, the lunar signal for 1,000 species to reproduce. When tides are highest at new moon and full moon, sea turtles come ashore at night to lay their eggs, the safest time to incubate the young. As the moon regulates tides, so tides regulate habits. Only at low tide do these sand-burrowing crabs emerge. On the Galapagos Islands, marine iguanas anticipate low tide by up to 2 hours. It gives them a head start on the way to the feeding grounds they share with fur seals. The French wine harvest. Growers here believe that at full moon, lunar influence is high and maximum energy flows to the grape. So in France, growers like to pick around full moon. And they rack at new moon, when lunar influence, they claim, is lowest, sediment least perturbed, and the wine clearest. Life on Earth is undoubtedly subject to the rhythms of the moon. What's now emerging is that the impact that formed the moon may have hastened life itself. Greenland, 1999, and a jaw-dropping discovery.
We are flying into camp at this very remote place in West Greenland, and you can only get here by helicopter. And from the camp, we will walk out to the site where we will open chapter 1 of the history of Earth.
3.8 billion years ago, this rocky outcrop is part of an ocean floor. As a native Inuit, Minnick Rosing is first to tap its secret.
So this is the oldest rock on Earth. This is the oldest material you can put your hand on, and if you want to touch something that's older than this, you would have to go to the moon to find it.
But moon rock, however old, contains no hint of life. Back on Earth, Rosing's Greenland rock does, and that's his great discovery. These layers contain carbon, evidence of complex plankton. That plankton exists so early predates previous estimates for the start of life by 200 million years, pushing it back closer to the lunar forming impact.
That was really mind-boggling experience because life was not supposed to be on Earth at that time, and if it was, definitely it was not supposed to be in life forms that could have lived in the open oceans.
Previously, early life is thought to exist only in extreme environments, feeding off the gases of deeply submerged volcanoes. This man brilliantly explains the Greenland findings. As a member of the National Academy, he advises the US government on science. Norman Sleep believes the moon-forming impact of Orpheus kick-starts life.
Earth Mach 1 died when Orpheus hit. This is Earth Mach 2. If we are on Earth Mach 1, we'd be now under 3 kilometers of water. We'd have no oxygen to breathe.
Sleep's theory is radical. Orpheus blows off half the oceans of Earth Mach 1 and conjures a new atmosphere. Quite possibly there's aquatic life on our protoplanet. Earth Mach 1 isn't short of water. Orpheus may have life too. But that impact takes no hostages.
The impact completely restores the Earth to a clean slate. Any life forms that existed on either the Earth or Orpheus, that was the end of them.
But his hunch is that Orpheus actually kindles life on Earth.
There may be a direct connection between life getting going on the Earth and the moon-forming impact.
Sleep believes that, like Earth Mach 1, Orpheus has an iron core. On computer, these cores are blue. So violent is the impact, they merge.
When Orpheus hit, large amounts of iron were mixed into the Earth. This iron reacted with water, produced hydrogen. This produced a reducing atmosphere, which is essential for life.